All right, guys. So you've made it to day 5 of the trig chapter. Believe it or not, I know some of you guys were complaining when I first mentioned that we were going to go into trig, and look how far we've come. But anyway, so now we're going to get into sine, cosine, and tangent. So this lesson's not too bad. The next one's definitely going to be tougher though. But anyways, so actually, story time. So I had this teacher in high school. I mean, the guy was really smart. He had his PhD and everything, but he wasn't exactly the greatest teacher. But I mean, I could have worked harder in his class for sure. But anyways, the reason why I bring it up is because he was my physics teacher, and he was Indian, so he had a bit of an accent. I could still understand him fine, but he said little things here and there that always made me kind of laugh, which looking at it now kind of makes me a jerk. But anyways, whenever we were doing physics and somebody would like sine, cosine, and tangent would come up, and he would always say if somebody didn't do it right, he would always just have this disappointing tone. He was like, "Oh no, you've got to know your SOHCAHTOA business." And to this day, I still remember it. It was hilarious. But anyways, so SOHCAHTOA is basically just if you haven't heard of it by now, it's just a way to memorize sine, cosine, and tangent. So first of all, let's go over the triangle. So as you can see here, I have this symbol inside the triangle that looks like a 0 with a line going through it. That is actually the Greek letter theta. And having a Greek letter theta, that's basically like a variable, kind of like how you have your x to represent unknown numbers. We just use a theta to represent unknown angles. So basically, this is a right triangle, but we don't know the measure of this angle. So that's why we just use this theta because it's unknown instead of an x. Now, so you have in the right triangle, first of all, sine, cosine, and tangent only works for right triangles. So you have to have a box in the corner. Now, assume that all the triangles that we do in here, if they don't have the box, you're assuming that it's a right angle anyways. But I'm going to try to make sure that I have the right angle every time. So looking at the right triangle, every right triangle has a longest side, and that longest side is called the hypotenuse. So this is the longest side, and it is called the hypotenuse. And the hypotenuse is always directly across from the right angle. So if you start at the right angle and you go across from that, that's going to be the hypotenuse. Or if it's an easier triangle to look at, you just look at the longest side. Then you have, looking at this angle theta, you have opposite and adjacent sides. Now, what does opposite mean from in terms of sides? Well, opposite just means across from. So if I'm looking at this symbol here, which side is across from that symbol? Well, it has to be this side that's all the way over here. So that is your opposite side. All right, and then the only side that's left is going to be your adjacent side. Adjacent just means next to, so these are the three sides of a right triangle. You have your hypotenuse, that's the longest side across from the right angle. Then you have your opposite side that if you look at the theta or whatever degree it gives you, across from that is the opposite, and directly next to it is adjacent. And so all trigonometry is based on sine, cosine, and tangent. And really, sine, cosine, and tangent are just ratios of the sides. So sine for a right triangle is going to be just a fraction, and it's going to be the opposite side over the over the hypotenuse. So you just basically just set up a fraction, opposite over hypotenuse. Cosine is going to be the adjacent side divided by the hypotenuse. And tangent is going to be the opposite side divided by the adjacent side. So that's where this acronym comes from, SOHCAHTOA, because this one is saying sine is opposite over hypotenuse, the middle one is cosine is adjacent in hypotenuse, and tangent is opposite over adjacent. Sometimes you'll see it written like this, and I actually kind of like this a little bit better. So it's so, and then S, and then O over H, Ka, and then TOA. So I kind of like that visual more just because it shows you how to set it up. But these are all just different ways of the same thing. These are all the same thing. Now, chances are you already remember it from geometry, but like my teacher said, make sure you know your SOHCAHTOA business. All right, so today's lesson is just setting up trig ratios. So basically just setting these up. Now, before you start, you need to label the three sides of the triangle. So start with the right angle, go across from that, and then that would be your hypotenuse. Or just look at the longest side of the triangle. So I'm just going to abbreviate hypotenuse to be HYP. And then you look for theta, so here it is in this angle, and go across from that, and that's going to be your opposite side. So go across from theta, and that is your opposite side. And the remaining one has to be the adjacent side, because it's next to theta. All right, so sine is going to be opposite over hypotenuse. So now we're going to use these numbers, these side lengths, to actually set up the real fractions. So sine would be opposite over hypotenuse. So that's 15 over 39. And then you would simplify it from here. So the largest number that divides into both evenly is 3. So if you divide by 3 on top and bottom, you get 5 over 13. Then for cosine, cosine is adjacent over hypotenuse. So adjacent is 36 and hypotenuse is 39. Simplify this. Again, 3 goes into both numbers evenly. So that would be 12 over 13. And then tangent's going to be the opposite side over opposite over adjacent. So the 15 and 36. Divide both of these by 3 and you get 5 over 12. So there are your 3 trig ratios for that one. So sine is 5 over 13, cosine is 12 over 13, and tangent's 5 over 12. All right, so next one, same thing. Start by labeling the 3 sides. So across from the right angle is the hypotenuse. And then across from the theta is going to be your opposite side, and the remaining one has to be the adjacent. So sine is going to be opposite over hypotenuse, so 30 over 34. That gives you, when you simplify it, divide by 2, so 15 over 17. Then cosine is going to be adjacent over hypotenuse, so 16 over 34. So that would be, again, divide by 2, so 8 over 17. And then tangent's going to be opposite over adjacent, so 30 over 16. Simplify that. So that would be what, 15 over 8 when you divide by 2. So there you go. So there's your 3 answers, your 3 trig ratios for this triangle. All right, last example. That way you can see. So I don't know if you've noticed, but the opposite and adjacent and the hypotenuse, they've kind of been switching around between the different triangles. So you really have to pay attention to how the triangle's oriented. All right, so last one. So here's the right angle. Across from that's going to be the hypotenuse. And across from theta is going to be your opposite side. And the last one has to be the adjacent because it's next to theta. All right, so then sine opposite over hypotenuse. So 8 over 12, does that simplify? Yeah, so both are divisible by 4, so 2 over 3. Then cosine is going to be adjacent over hypotenuse, so 5 over 12, which does not simplify, so you just leave it. And tangent is going to be opposite over adjacent, so 8 over 5, which also does not reduce. So there you go. 3 trig ratios, so that's what we're setting up right now. And remember, all of this stuff is all going to come together on the next lesson. So, or is it the lesson after that? I think it's the lesson after that. But anyways, now, I was on Instagram the other day and then I found this meme and now I'm going to share it with you guys. Just because I thought it was kind of funny. I hope you understand it. Absolute value. Anyways, homework time. All right, so here's your homework. You're finding the 3 trig ratios, sine, cosine, and tangent for all 3 of these triangles. Like I said, I'd recommend labeling them first and then figuring out the 3 trig ratios. As always, make sure to message me if you have any issues or if you just want to say hi.